Have you ever wondered why the Pioneer spacecraft, launched in the 1970s, veered off their predicted paths as they neared the edge of our solar system? This unexplained behavior is known as the Pioneer Anomaly, a cosmic mystery that has puzzled scientists for decades. Despite our advanced technology and understanding of space, we have yet to pin down a concrete explanation. But that doesn't mean we're short of theories. Stick around to explore 10 intriguing theories that try to explain this cosmic conundrum. First up, we have the theory of gravitational anomalies. In the vast expanse of space, gravity is the invisible force that keeps everything in check. It's what keeps our feet on the ground, the Earth in orbit around the Sun, and the entire Milky Way spinning in its cosmic dance. But what if there are places where gravity behaves unexpectedly? This is the concept of gravitational anomalies. Imagine there are pockets of space where gravity is stronger or perhaps weaker than what our equations predict. Could these gravitational anomalies be influencing the trajectory of the Pioneer spacecraft? This could be due to unaccounted gravity from dark matter, an elusive substance that we know exists but have yet to fully understand. Or perhaps there are undiscovered celestial bodies exerting their gravitational pull on the spacecraft, nudging it off course. Could the unaccounted gravity from dark matter or undiscovered celestial bodies be causing this? This theory certainly provides food for thought as we delve deeper into the Pioneer anomaly. Moving on, we delve into the possibility of gas leaks. Imagine the spacecraft as a deflating balloon. When air, or in this case gas, escapes from a confined space, it creates a force that pushes in the opposite direction. Now apply this concept to the Pioneer spacecrafts. It's plausible that a slow, steady leak of propellant or other onboard gases might have nudged the spacecraft off their expected trajectories. The leak wouldn't have to be large, just consistent enough to create a persistent, unaccounted-for force. It's like a tiny, invisible hand, gently and persistently pushing the spacecrafts off course. This theory, while seemingly mundane, would have profound implications. It would mean that our understanding of space might be skewed by something as simple and as overlooked as a gas leak. So here's the intriguing question we are left with. Could the answer be as simple as a slow leak? Next, we tackle the theory of radiation pressure. You might wonder, what exactly is radiation pressure? Simply put, it's the pressure exerted by the electromagnetic radiation on any surface it encounters. Now, let's consider the Pioneer spacecraft. Its power supply, a radioactive isotope known as plutonium-238, emits heat as it decays. This heat can be converted into electricity, which powers the spacecraft. But here's the twist. As this heat radiates outwards, it also exerts a tiny force on the spacecraft. Although this force is minuscule over vast cosmic distances, it could have a significant effect on the spacecraft's trajectory. This effect is similar to a gentle breeze pushing a leaf off its course. So is it possible that this radiation pressure could have nudged the Pioneer spacecraft off its expected course, creating the observed anomaly? Could minute forces from radiation pressure be responsible for the Pioneer anomaly? Our fourth theory involves thermal emissions. Imagine the Pioneer spacecraft journeying through the vast cold of space, its onboard systems generating warmth to keep it functioning. This heat doesn't just disappear into the void. Instead, it radiates away from the spacecraft in all directions. But what if this process isn't perfectly symmetrical? If more heat is emitted in one direction than another, it creates a small, steady force. Think of it as a gentle push, nudging the spacecraft ever so slightly off its intended course. Over time, these tiny deviations start to add up, resulting in the anomaly we're trying to explain. It's a bit like a space version of a hot air balloon. The heat generated by the balloon creates lift, altering its path. In the case of Pioneer, the heat could be creating a similar effect, subtly changing its trajectory over the vast distances of space. Could the heat generated by the spacecraft itself have nudged it off course? Halfway through our list, we encounter the theory of drag forces. Now you might be wondering, drag forces? In space? Yes, indeed. Although space is often thought of as a perfect vacuum, it's not completely devoid of matter. There are tiny particles scattered sparsely throughout the cosmos, and these could, theoretically, exert a drag force on a spacecraft. Imagine for a moment you're a Pioneer spacecraft. You're moving through this sparse cosmic ocean, and every now and then you encounter these tiny particles. They might not seem like much individually, but over time they could slow you down, ever so slightly. This is the essence of the drag force theory. This theory, however, poses more questions than it answers. If the drag forces were strong enough to affect the Pioneer spacecraft, then why aren't they affecting other spacecraft as well? Or are they? Might the drag forces in the vacuum of space be stronger than we thought? If you're enjoying this deep dive into the mysteries of the Pioneer Anomaly, don't forget to do a few things. First, subscribe to our channel for more intriguing space theories. We're always exploring the unknown, and we'd love for you to join us on this journey. Second, give this video a like to support our content. Your likes help us reach more people and share these fascinating theories with the world. And lastly, we want to hear from you. Comment below with your thoughts on the Pioneer Anomaly. Do you have a theory we haven't covered? Do you agree or disagree with the theories we've discussed? We're eager to hear your thoughts. Now, let's dive back into our exploration. The sixth theory suggests we may need to modify our understanding of gravity. Yes, you heard that right. We might need to reconsider one of the fundamental forces that shape our universe. But why? Well, our current comprehension of gravity is based on Newton's laws and Einstein's theory of general relativity. However, the Pioneer Anomaly might challenge these established theories. The unexpected changes in the spacecraft's velocity suggest that our grasp of gravity could be incomplete or incorrect. Imagine gravity as a puzzle. We've been working on it for centuries, and we've managed to fit many pieces together. But what if there are more pieces we didn't know about? Or worse, what if some of the pieces we've placed don't actually fit? The Pioneer Anomaly could be telling us that we've missed something crucial about gravity. So here's a thought to ponder. Could our fundamental understanding of gravity be flawed? This theory might seem radical, but sometimes radical ideas are what lead to groundbreaking discoveries. Next, we consider the impact of tidal forces. Now, what are tidal forces? These are the gravitational effects that cause the stretching of an object, like the way our moon tugs on Earth's oceans to create tides. But could these forces have played a role in the Pioneer Anomaly? In space, tidal forces can shape the trajectory of a spacecraft. Imagine a celestial body, such as a planet or a moon, pulling on the spacecraft. The side of the spacecraft closer to the celestial body feels a stronger pull, while the side further away feels a weaker one. This difference in gravitational pull can create a stretch or squeeze effect, potentially altering the spacecraft's path. However, the Pioneer spacecraft were far from any large celestial bodies when they experienced the anomaly. So, while tidal forces can certainly influence spacecraft trajectories in certain scenarios, their role in the Pioneer Anomaly remains uncertain. Could tidal forces have subtly altered the spacecraft's path? We're still exploring that possibility. Moving on, we explore the possibility of an onboard systems error. Now remember, the Pioneer spacecrafts were technological marvels of their time, but they were not perfect. Just like any machine, they had the potential to fail or malfunction. So let's consider this theory. Could it be possible that the unexpected changes in velocity were not due to some exotic force or unaccounted physics, but simply a result of some error within the spacecraft systems? Perhaps a malfunctioning thruster, a misread sensor, or even a programming error. It's a humbling thought, isn't it? That our grand quest to understand the mysteries of the universe could be thwarted by something as mundane as a faulty component. Yet, this theory cannot be dismissed outright. The Pioneer Anomaly remains unexplained, and every possibility must be explored. Could the spacecraft itself be responsible for the anomaly? Our ninth theory involves electromagnetic forces. Now, we know that electromagnetic forces are incredibly powerful. They hold atoms together. They're the reason magnets stick to your fridge, and they even power our homes. But could these forces have affected the Pioneer spacecraft's trajectory? Well, considering the spacecraft's construction, it's not entirely out of the question. The Pioneer spacecrafts were made of metals, which we know are excellent conductors of electricity. Space is not a true vacuum. It's filled with charged particles from the sun and cosmic rays, creating a sea of electromagnetic fields. As the Pioneer spacecrafts moved through this sea, they could have interacted with these fields, leading to tiny changes in their velocity. While the effect might be small, over the vast distances and time scales of Pioneer's journey, even tiny forces can add up. So, the question we're left with is this: could forces we usually ignore in space travel calculations be at play here? Finally, we delve into the theory of cosmic strings. Cosmic strings, if they exist, are one-dimensional defects in space. Think of them as invisible threads, incredibly thin but unimaginably dense, stretching across the cosmos. They are thought to be leftovers from the Big Bang, a relic from the early universe when it was still cooling down. Now, how can these cosmic strings explain the Pioneer anomaly? Well, if a Pioneer spacecraft passed close enough to a cosmic string, the intense gravitational field of the string could have caused a slight change in the spacecraft's trajectory. This, in turn, would appear as an unexpected change in velocity from our point of view here on Earth. This theory, like all the others, is still speculative and requires more evidence to be confirmed. But it's fascinating to consider that these ghostly strings from the dawn of time could be influencing our exploration of the cosmos. Could these hypothetical one-dimensional defects in space be the cause of the Pioneer anomaly? As we've seen, the Pioneer anomaly remains a tantalizing mystery in space exploration. From gravitational anomalies to gas leaks, from radiation pressure to thermal emission, and even the possibility of cosmic strings or altered laws of gravity, each theory adds a unique twist to this enigma. It's a cosmic puzzle ever reminding us that the universe isn't as simple as we might think. The quest for answers continues, reminding us that the universe still holds many secrets waiting to be unraveled.